Right, this video is over atomic structure, and as you can see, our understanding of the atom has changed throughout the years. So the first people to think about atoms were the early Greeks, but they thought atoms were just earth, fire, air, and water. John Dalton was the first one to actually experiment and come up with ideas based on experimentation and not just reason like the early Greeks did. So after his experiments, these were his postulates or his ideas. And he said all matter is made of atoms, so that's true. Atoms of an element are identical. This one is not true, and y'all need to know that, and we'll go over why that's not true in the next video. Each element has different atoms, true. Atoms of different elements combine in constant ratios to form compounds. That's true, right? For every 3 carbon, you need 8 hydrogen for this specific compound. And if you change these, then you change your compound. And atoms are rearranged in reactions. That's true. And then this is what Dalton thought the atom looked like, just like a hard, solid sphere. Then comes J.J. Thomson, and he used the cathode ray to find the electron. So this is a cathode ray tube, and it's just a vacuum, and he shot electricity through it. And when he did that, it curved toward this positive magnet that he had, and not towards the negative magnet. So then he decided, well, okay, since it's being attracted to the positive plate, it must be negative. This electricity, these electrons, must have a negative charge. So this is what JJ thought the atom looked like. He thought it was plum pudding. I guess the English eat a lot of plum pudding. He thought it was just this positive gel, and embedded were these negatively charged electrons. So we call his model the plum pudding model. Then comes along Rutherford, and he shot alpha particles at gold foil. And so they knew that alpha particles had a positive charge from earlier experiments, and he would sit and count flashes in the dark. And every time he saw a flash, that means that an alpha particle hit the nucleus and bounced off. Now, a lot of them did not deflect. They just went straight through. So they knew how many they were shooting at, and so he concluded that the nucleus is small because you didn't get a lot of deflection. It's dense, and it's positively charged because it bounced off. If it was negatively charged, they'd be attracted to each other and stick. So here's the subatomic particle chart. Electrons have a negative charge, protons have a positive charge, and neutrons have no charge. Electrons are found outside the nucleus. Protons and neutrons are found inside the nucleus. So you know that most of the mass comes from the nucleus due to the protons and the neutrons. Alright, so finding data on elements. Each square of the periodic table includes its atomic number, its chemical symbol, name, and atomic mass. So this is how you would write it. Your mass number is your rounded version of your average atomic mass, and this is just protons plus neutrons. Your atomic number is the number of protons, and this is how you identify atoms, because your number of protons never ever changes. Now, in a neutral atom, it's also the number of your electrons, but that's in a neutral atom, and we'll talk more about that in the next video. And then the X is whatever your element is. So this is how you read it on the periodic table, but this is how you write it. So if you notice, it's flipped, and this is the mass number. It's the rounded version of your atomic mass. All right, so try these homework problems, and we'll discuss them in class.